Moments. Rotational effective force on a body about an axis is called moments. For example, when doors open, there is a rotation of door about the hinge. How to find the moments about a point? Moments can be found by force times perpendicular distance. Let us discuss an example. Two children, A and B, are sitting on a seesaw, as shown in the figure. The seesaw is balanced. Calculate the moment of child B about the pivot of seesaw. We know that moment of force equal to force times perpendicular distance. Here, force is equal to the weight of the child, which is 280 Newton, acting down. The perpendicular distance from the pivot is 90 centimeter. We have to convert centimeter into meter. So 90 divided by 100 meter. Substitute the value of force and perpendicular distance. In the equation 1, we get moment of force equals force times perpendicular distance, that is, 280 times 0.90 meters, which is equal to 252 Newton meters. Why we need to know about moments? Do they have any importance in daily life? Yes, moments play a key role in balancing an object. If an object has to be in rotational equilibrium, it should obey principle of moments. That means clockwise moment is equal to the anti-clockwise moment. Now let's have a look at clockwise moments and anti-clockwise moments. For calculating moments, we have to select a pivot that is a point about which your object is going to rotate. For example, if we consider a clock, this is the pivot, which means clock hands are rotating based on this point. So the moment about the pivot is called clockwise moments. Anti-clockwise moments. If the force on the body is to turn it in anti-clockwise direction about pivot, then the moment of force is anti-clockwise moment. Let's see an example. Check the given beam is in a balanced condition. According to balancing condition, clockwise moments equals anti-clockwise moments. So to find clockwise and anti-clockwise moments, I have to select a pivot, and this is my pivot. Now let's identify the clockwise moment first. For that, keep the pivot of clock in close to the pivot of the beam, and check which of the forces are moving in the clockwise direction. So here, the external 5 Newton force is acting in the same direction of clock hands, which means 5N is in clockwise direction. To calculate clockwise moment, we have the equation. Clockwise moment equals force on clockwise direction times perpendicular distance. Here, the perpendicular distance is equal to 6 centimeters. So when we converted the distance into meters, we get 6 divided by 100 equal to 0.06 meters. So clockwise moment is equal to 5 Newton times 0.06 meter, which is equal to 0.3 Newton meter. Now let's focus on 25 north. As we did earlier, keep the pivot of clock on the pivot of beam and check in which direction 25 newtons is acting. Here, 25 Newton is acting on the anti-clockwise direction. So to find anti-clockwise moment, equation is anti-clockwise moment is equal to force on the anti-clockwise direction times perpendicular distance from the pivot to the force. Here, the perpendicular distance from pivot to force is 3 centimeter, which we have to convert to meter like earlier. So we will get 3 divided by 100, which is equal to 0.03 meter. Now, anti-clockwise moment is equal to 25 times 0.03, which is equal to 0.75 meters. Now let's check our beam is balanced or not. Clockwise moment equals 0.3 Newton meters. Anti-clockwise moment equals 0.75 Newton meters. According to principle of moments, if clockwise moments equal to anti-clockwise moments, beam is balanced. But here, clockwise moment not equal to anti-clockwise moment. So beam is not balanced. Let's solve a question based on moments. Two people are on opposite sides of a seesaw. Person A is 1 meter away from the pivot and weighs 200 newtons. Person B weighs 800 newtons. How far from the pivot would person B need to sit to ensure they are in equilibrium? To solve the problem, we can create a sketch of the given problem. So this is my seesaw and 2 persons are sitting on the seesaw. The first person is person A and second one is person B. This is the pivot about which seesaw is moving. Now let's mark the given data in the sketch. Person A is 1 meter away from the pivot, so we have to mark 1 meter here. Weight of the 2 persons are 200 Newton and 800 Newton respectively. Since weight is always acting perpendicular to downwards, we can mark both weights like this. What we need to find is the distance of person B from the pivot if the seesaw is in equilibrium, so we don't know the distance. Let's mark it as x. We know the condition of being in equilibrium is clockwise moments is equal to anticlockwise moments. To find clockwise moment, we have equation, force on clockwise direction, times perpendicular distance from the pivot to force. So consider the pivot as center of clock and identify which force is acting in clockwise direction. Here, 800 Newton is acting in the clockwise direction. Perpendicular distance to 800 Newton is x. So clockwise moment equals 800 Newton times x to find anti-clockwise direction. Follow the same method as we did earlier. We get 200 Newton is acting in the anti-clockwise direction. Perpendicular distance to 200 Newton is 1 meter. So anti-clockwise moment is equal to 200 Newton times 1 meter, which is equal to 200 Newton meter. Substitute the values of clockwise and anti-clockwise moment in equilibrium condition. We get 800 times x is equal to 200 Newton meter. So x equal to 200 divided by 800 equal to 0.25 meter. So the person B has to be 0.25 meters away from the pivot of seesaw. For more physics videos, like, share, and subscribe.